Katie McCarthy with the Education Department at the National Air and Space Museum. Thanks for tuning in today. In 2020, we celebrated the 20th anniversary of the International Space Station, or ISS. Today, we'll be talking about the technical challenge of building a craft the size of an American football field outside of the Earth's atmosphere. Before that, though, I'd like to talk about where in space the ISS actually is. Here, I have a model of Earth, and Shannon, behind me, has the Moon. They are to scale, which means they are relatively the same size to each other as the actual Earth and Moon. If you're doing this with your classroom, this Earth model has a diameter of 12 inches, and the Moon has a diameter of 3 inches, which you can roughly replicate using a basketball and a tennis ball. Shannon is 30 feet away, which at this scale is almost 240,000 miles in space. Now, we know that the ISS is about 250 miles above the Earth, which is roughly the distance between Washington, D.C. and New York City. This coin is going to represent the ISS. Again, using the scale, that places the ISS this far away from the Earth, which is actually pretty close by. One way to talk about the space station's place in orbit is to talk about scales and ratio, like we've been doing so far. Another way to do so is by focusing on what it took to build the station. The International Space Station was built through collaboration between 5 different space agencies. 15 different countries worked together to manufacture and send to space the parts it needed. ISS parts have been made and launched from all over the world, but largely from Russia and the United States. Once in space, these parts are added to the station by crew members on spacewalks and by using tools like Canadarm, which we'll talk about later. The ISS took over 10 years, 34 shuttle missions, and hundreds of engineers, scientists, and crew to build. Zarya, the first module of the ISS, was launched by the Russians in November 1998. It was followed quickly by the NASA module Unity, and American astronauts aboard the Space Shuttle Endeavour attached the 2 parts. The ISS became habitable after a 3rd module, Zvezda, was attached in July 2000. Behind me is Endeavour's sister ship, the Space Shuttle Orbiter Discovery, the busiest shuttle in the fleet. Discovery spent 365 days in space, over 39 missions. Although astronauts aboard Endeavour helped attach the first 2 modules of the ISS, Discovery was the first orbiter to dock with the space station in 1999. It visited the ISS 13 times, carrying trusses and modules to add to the station on 6 of those missions. The ISS is special because it makes it possible for humans to have a continuous presence in space and to carry out scientific research not possible anywhere on Earth. Over 240 individuals from 19 countries have visited the ISS, and over 3,000 investigations have been carried out aboard the station. These investigations include studying animal, plant, and human biology to find out how it is affected by the microgravity of space. One of the tools on the ISS is the Mobile Servicing System, a robotic system that helps crew members to assemble and maintain the space station. Included in the Mobile Servicing System is a robotic arm called Canadarm2. Just like it sounds, Canadarm2 is a large robotic arm developed by Canadian engineers. When its 7 joints are fully extended, it is 58 feet long. Before the ISS had a Canadarm, the Space Shuttle fleet was outfitted with them. Behind me, you can see Canadarm1, the robotic arm that flew with Discovery and helped to build the ISS. Canadarm2 is now almost 20 years old. It was added to the ISS in 2001. If you could redesign Canadarm or build your own, what would it look like? My colleague used materials she had at home to make her own robotic arm. You can build it out of whatever materials you have at home too. Part of what we love about this challenge is how many different ways our team tried to answer it. How about you? What design can you or your students come up with? If you try this challenge, send us your results. Thanks for tuning in today.